Hi, I'm Savik. I work at Canonical on the Mir team. And I have to apologize for the bait and switch, but we've only made our work public on this last week. So in fact, this talk is going to be about Flutter on the desktop. It's something unusual to us, but the work we've done over the past few months is actually done on Windows. And if you want to run out, now's your chance. That's the biggest Flutter community that's out there, so we wanted to enable them to develop great apps that will feel in place on all desktop platforms, current and future. We're also an unusual group to be going at it. We are mostly involved with the other side of the story, on the compositor side, but that actually gives us a unique view on the problem and how we want to tackle this. So real quick on the agenda, we will kind of talk through a brief history of Flutter and Flutter at Canonical and at Ubuntu in particular. We will have Alan teach us what it means to integrate with the desktop in the way that we think is worthwhile. And then we will actually show a couple demos. Last week we proposed some things to the Flutter engine and framework. We made it so that that you can very easily migrate your existing current material app to something that is very in place at a desktop compared to what it was before. Matt's going to show us how to do this on material, and before that, Harlan's going to show us like what are all of the tools available to framework and application developers in this story. So first, we have Robert involved with all Ubuntu's efforts around Flutter from the beginning, and he'll tell us about that journey.
Thank you very much. So, yeah, as I said, my name's Robert Ansell. I've been involved in Flutter and Canonical for quite a few years now. So Flutter basically came out around 2017. That was the first sort of release you could have built something with it. It's a cross-platform UI development toolkit. So we're interested in that with Linux. The project was first announced around 2015, so not that much before that. And yeah, even though Flutter is really successful on mobile apps, it also supports the web and desktop. The vision for the project's always been build for any screen. So why did we get involved with Flutter at Canonical? One thing was to develop our own apps. To start, we started with the new software store. So what actually happened is I proposed a new software store within Canonical. The answer was yes, we could do it, but as long as we did it in Flutter. Ended up on a very, very long tangent, then enabling Flutter on Linux before we could come out with our new software store. We also were interested in encouraging developers to target Ubuntu, so it's very hard to get people to target things like older toolkits like GTK if they're not from that environment. There's a large Flutter audience, as we said, on Windows. If they can develop for Windows, they can hopefully develop for Linux as well. So yeah, so we engaged 2019. That was when we talked about this new software store. We reached out to the Flutter team at Google and said we're really keen to work on this, and they were really keen to work with us. So we work very closely with them. We have regular meetings every 2 weeks. We're seen as the sort of the maintainers of the Linux embedder. Yeah, we built this new embedder. So when I started on it, there was a GLFW embedder, which was kind of a proof of concept. We then built on top of GTK to build support for Linux, and then just features and features and features until now to do that. We also worked on native dbus support. So if you're familiar with dbus, it's the way that all the system services in Linux communicate with each other pretty much. So we could have done that by having native code that would bridge across to Flutter, but we decided to make native support for that in Dart, and that required working with the Dart team to support Unix sockets. And once we got all that to work, that just opened up a huge amount of stuff you could access suddenly from Flutter on Linux. So here's sort of the brag page. So we have 38 packages in pub.dev that are maintained by Canonical. Lots of dbus packages that access things like, what have we got there, like desktop notifications, network manager, all those services. We have bindings for that. We've landed more than 200 pull requests now upstream on the engine and the SDK and the plugins. So that's going really well. We're constantly landing stuff there. Yeah, and then next we have Alan. Thank you.
So you can just go for this. Yeah, we have Alan's. Alan's been with us on the Mir project since its inception, and yeah, he will take us through what it means to integrate with a desktop platform.
Thank you. So, well, our aim, as was mentioned earlier, is that Flutter apps should just work across all the desktop platforms: Windows, macOS, Linux, and the variants of those. So, why was the Mir team involved in this? Well, we've got a long history of working across different types of devices because we started off working with phones and desktops, and that had a lot of things to do with how applications can present on those. So we've got a lot of experience of what Windows mean on different desktop environments, and not just Linux. We've looked at Windows and macOS as well. And they're different, but largely it's an appearance difference. Lots of things are the same. You know, if I talk about a drop-down list, then you know what I'm talking about, whether you're on Windows or macOS or Linux. And it's the same with Windows. There's certain types of windowing that make sense. So drop-down lists make sense as being a separate window, and as part of the compositor team in Mir, you know when there are windows appearing that you don't even think of as windows in your normal operation, but it looks really weird if things are not. So we've come up with the canonical types of, sorry, excuse the pun, the canonical types of window that you might have when you're running an application, and these are the things we think you need to have. The other things that you need with desktops is integration on your input, such as your keyboard, pointer and mouse, and with assistive technologies. And we know the compositor side of that and how to integrate that into applications. So the approach we've taken with Flutter is to make it easy to do the common stuff. Easy to create regular windows, drop-downs, menus, tooltips, and the rest. And we're going to integrate that stuff with each of the desktop environments. You're going to see shortly the work done on Windows. We're shortly going to be starting on work on macOS. And we know that eventually we'll get round to Linux because that's very dear to our hearts. Trust us, we will get there. And next, I'll hand over to Harlan.
All right. So while Harlan gets set up with the demo, this is going to be at the demo section of our talk, and Harlan's been working on the on the Win32 side of things. So how does a Flutter thing translate into a Windows thing? So he's going to show us like all of the tools available to a Flutter developer, whether it's a framework developer or an application developer, to express themselves, express the intent about the windows that they're creating, so that when Matt then goes and creates a tiling window manager, it doesn't all go to. There was a toilet talk at the main room just before, so that's just it. Harlan, take it on.
Okay, hello. So as Savik said, I've been working on the development of multi-window support for Flutter on Windows because Windows was the platform that has the most developed multiple window support already. So we are going to see now a demonstration of a Windows application in Ubuntu Summit. So we have here this reference application that allows the user to create different types of windows, the window types that Alan mentioned. So this is a top-level window, a regular window, and here I have specified here that this is a regular window with the view ID 1, which means that this native window has a Flutter view associated with it, and it has the ID 0. So I can create a new regular window here. So this is a new Flutter window with a new view. Now this is the view 1. And I can go further and create new windows here, or just use this button here. And there you go, I have a couple top-level windows. I think I can see them in this test switcher here, yes. They are separate top-level windows. Okay, so let's create some dialogues now. Oh, the thing is, these regular window with view ID 0 is selected here. So if I create a dialog now, it will be assigned as the child of these regular windows. So I'll do that. And now I have this modal dialog. It has the main window as parent, and I can't click here because it's a modal dialog. But I can also create a modeless dialog. Let's unselect this and now create the dialog. It's now a top-level dialog, and I can switch between these windows. The dialog will appear in the test switcher. And I can close it here. When I push that button internally, we are calling a destroy window method over the method channel in the windowing channel. So I can either close the window by using this close button or the window close button. So now for the satellites. Here they are grayed out because satellites and then pop-ups can need to have a parent, so I'll select my main window, and now I'll create a satellite. For satellites and pop-ups, they use positioners, and these positioner is much like what the positioner of XDG shell. We have an anchor rectangle where we can specify anchor points for the parent and for the child and offset between them. So, but I will talk about that later. For now, I'll just create the satellite using these left presets. So it will be placed to the left of the parent window. And now let me create a satellite to the right, like so, okay. And I can move the main window and the satellites will move along. I can reposition them. So the satellites will work like two boxes. For example, like in GIMP. And I can create another regular window. And when I do so, the focus now is on this new window. It's the new active window. And when that happens, the satellites of the previous window will become hidden. To avoid cluttering the screen, let me create a satellite for that new window. Oh, now they're back because the main window is active again. But I'll create a satellite for that one. Again, the satellites of the main window become hidden, and this is the active one. I can switch between them so you can see the behavior. Okay, and let's show the pop-ups. So pop-ups need a parent, and okay, using the right preset, let's create a pop-up. So this is a pop-up window that works like a menu. Pop-up can have a child, like a menu can have a submenu, and I can interact with it. I can, if I click on the parent, the sentence will close, and if I click somewhere else, the pop-up will be gone. So let's. Oh, well, I can also show here in this regular window, there is this child pop-up which will create a pop-up centered in this window. And again, I can create as many children as I want. Okay, so let me talk a bit about the positioners. Let's create a custom preset here to say create a child window that has its top left corner anchored to the top left corner of the parent. So let's just reset these things because I'll talk about them later. The offset. Okay, so we have by default here the anchor rectangle encloses the client rectangle of the parent. So here I'm just specifying the anchors, the parent anchor in that anchor rectangle. So for the parent, it will be the top left corner. So it will be around here, the top left corner of the client rectangle of the window. That's the top left corner of the view. And for the child, also the top left, because I want the child window to be at the top left corner of that window to coincide with the top left corner of the parent. Okay, and if I create now a satellite, we have this result. Now let me show you what happens if I change the offset, 150. It's displaced by the corresponding offset. Okay, so another thing that may be interesting is that, so let me just reset here to 0. Okay. Okay, so for the pop-ups, it works the same strategy. But here you can notice that the pop-up is anchored to the top left corner of the client rectangle. And sometimes the users may want to anchor the child windows to the window itself, to the window frame itself. So we allow that by specifying a null anchor rectangle. Here I'll just check this checkbox. And the result will be like so. Now it's anchored to the top left corner of the window frame. Okay, there's one more thing that I need to talk about is these constraint adjustments. So here we don't have any adjustment set, but I've just used some anchoring like the left preset. So left anchor to the parent, child, the right anchor to the child, and the result will be something like that, like the left preset. But if my main window is like so, and I don't have much space to the left, what will happen here? Part of the satellite is outside of the screen, but the user can then specify which adjustment it would like the compositor to take into account for placing the child window back again to an unconstrained position. So if I select slide, for example, slide in the X direction, now if I create the satellite, the compositor will use this slide strategy to adjust the placement so it won't be constrained anymore. And there is also the flip strategy. It will flip the anchor points from the left to the right. And the resize strategy. It will resize the window so the placement is not constrained. And I can select all of them because it's like a bit mask. Well, the same works for Y, but here I'm just demonstrating the X. So for example, if you have both sides constrained, the compositor will follow an order of precedence. So first it will try the flip strategy. If the flip strategy doesn't work, that is, if the new placement is still constrained, then it will proceed to the slide. And if it's still constrained, to the resize. So let's see what happens with the satellite. So yeah, it used the slide strategy because the flip didn't work first. And I think that's all I had to demonstrate. And now to Matthew. Thank you.
Did I break it? No, I didn't. Okay, so I think one major thing about this is, yes, you could all do this as an application developer, and you could all do this positioning like in your app logic, but then you end up in a platform that just can't do this. Like you could write this app and have it run on Android, and so what then? What happens with all of those dialogues? What happens with all of those, all of the things that you did to make your application behave great? The reason why we're building this as a developer-facing API is that as long as you kind of can think within those constraints, then the compositor, or first the platform on Windows, can make a meaningful call, make a meaningful decision on the particular platform. And also, by the way, in the particular situation that you're in, because if you connect a big screen to your Android phone, then it can behave completely differently than it can on a mobile, right? So we're building into all of this a way for kind of falling back to, if satellites don't make sense or a dialogue doesn't make sense on a platform, then the platform will tell you, and you can, as an application or framework developer, just take a step back and so what then? I will make my app behave right. And so Matt has been working on those higher level interfaces. As an application developer, you probably don't want to deal with what Harlan was showing you, and you actually just want the dialogue. You actually just want a drop-down menu. And so that's kind of, we're working our way through like both ways of the API. So Matt's going to show us that now.
Cool. Can you guys hear me? Yep. Hello, everyone. And I'll need the screen changed. Okay, great. So my name is Matt. I am mainly working on the framework side of this whole dance. So that is the Dart code side that people are actually going to interact with, all the material APIs and whatnot. So what I'm showing you here is actually a little example application that I built using Flutter's built-in material APIs. And this is just using the single window constraints as they have it right now. So if you've ever written any Flutter code before, this should look kind of familiar to you, the constructs I'm working with here. So up top, I have like their menu anchor and toolbar and everything. You could see if we have an overflowing toolbar, it simply gets constrained to the actual window size. So, this one changes the color of the app, and you can see it's just this little thing. Right, it gets constrained. Same with this pop-up. When we scroll over this little tooltip right here, it again gets constrained to the window. It gets modified in that direction. When we open up the dialog, again, the dialog is within the same window. And if this dialog actually has a dialog as well, which also appears in the same window. So they have this kind of navigator idea for those of you familiar with Dart and Flutter. And they push to the stack, and then as you go back, you pop off the stack. I have these buttons here, but obviously you can't open a second window. You can't open a true toolbar in Flutter as it stands, so they are nothing. And then up here, I have another pop-up that shows, a little context menu that you'd see in many, many applications. So what we did, and what I'm going to show you now, is how we can take Harlan's constructs. Oh, you need it bigger? Hold on. Enhance. There we go. Yep, so this is that application I was just running. You could see yep, that is the application. And you could see it's pretty standard Dart code if you've ever seen, or Flutter code rather, if you've ever seen Flutter code before. And I'm going to show you how just with a few simple lines, you could take this existing application, and everything that Harlan showed you in the last application will be built in for you within the material API underneath the hood. So you won't have to think about, am I creating a pop-up? Where's the constraint adjustments? All of that will be available for you to tweak through the API, but you really won't have to think about it so much. So the first thing, and this is going to seem like a lot of magic, but if you're at all familiar with Flutter, you know that this runner code gets generated for you by default whenever you start a new application. And it is a considerable amount of boilerplate code. So when we're migrating to using from a single window application to a multi-window application, we need to change the runner code so that it doesn't create that initial window for us by default, because we don't want that anymore. So I'm just going to come here, and again, this is going to seem like a considerable amount of magic, but I am going to delete that Windows folder and put in a new Windows folder. Like I said, once this gets merged completely upstream, this will be completely transparent to you. You'll just Flutter create project, and all of a sudden, you have a multi-window application. So that is step one. So now we've replaced the runner code. We have the new runner code. All should be good. And in fact, as it stands now, our single window application would no longer be valid because there is no window that it could render into. All right, so what code changes do we need to shift this all over to multi-window? So the first thing is instead of doing this, yeah, and you can see that okay, I could even enhance a little bit more. Is that good? Maybe I could go like this. Maybe I could go like this. Okay, cool. So instead of using run app, we're going to use this new construct called run widget. What this does is it doesn't assume there's an initial window there. It just doesn't assume the implicit view at all. And what we're going to do instead of just running my app is supply it with a multi-window app. Now, by wrapping your entire application in a multi-window app, you're telling Flutter, okay, or the Material API, okay, whenever multi-window is available to you, I want you to try and use it. So whenever it's going to show you a pop-up from now on, it's going to show you a true pop-up. And this takes a set of initial window functions. Because like I said, you don't have a window anymore. So we are going to, I believe this also takes a build context. This is a function that takes the build context and returns a window. So we are going to return the regular window. And let's give it a nice size, 900 by 720, I don't know, that might be okay. And it's going off the screen, Right, and then here in this builder function is our widget builder. So in this case, we have a build context here, if it does the thing, and we're going to return my app. Cool. So now this run app thing can go to the grave because we have a brand new run widget that returns a regular window. And we can stop there. And I believe I had that, sorry, I had it over on this screen. Yep, so this is, again, this is still the single window app, if you guys remember it. I will X out of there, and I will rerun Flutter. I don't know how to make the terminal bigger in Windows. I'll rerun Flutter. Now, you see that if you can squint your eyes, the command is much larger here because I'm pointing at my local engine because that's the one that has the multi-window support, whereas before I just did a Flutter run because I didn't need multi-window support. So if I run that here, hold on, let me Flutter clean because it's not going to like that. Which means that'll take a minute. Maybe 2 minutes. Yeah, if anybody has any comments.
Mike, please, yeah.
Do you anticipate when the multi-window stuff is upstream that hot reloading of your multi-window apps will work?
Yes, it should. At the moment, it's a bit broken. We also have to figure out how we're going to do it, because obviously a window could be tied to a state. So we have to kind of be smart about tearing those down and understanding that they're nested, and that's the piece that's missing at the moment. No, it's okay. See any good movies?
You said that you're developing at Windows at the moment.
Yes.
I have Flutter apps running on macOS, which run perfectly. So, and you said that also you were developing for all the desktop apps, so Linux, Windows, Mac. Mm. So what's the difference then between the Mac version, or you're not involved in the Mac version? Or?
So we will be involved in developing the Mac version as well. The difference there is that we have to develop another embedder to support multi-window.
Fair enough. And why, perhaps later we can have a look, because my Flutter apps at Linux, which used to work, don't work anymore. So I don't know what it is, but you can have a look later at it.
Yeah, that sounds good. That might be another task. Yeah. All right. Oh, wait, do we have another question? Or? Okay. It is loaded. So now, it's going to be a little slow because I'm in debug mode with everything right now. But you could see, oh, wait, I made my window too big. Let me make it a little bit tinier. you can see that this will be actually a true surface now. So you can see it extends beyond it. It works just the same. I can change the purple there, is so subtle. Orange, okay, orange is good, even that's subtle here. But you can see it works exactly the same, except you have a surface. If I go here, now my tooltip extends beyond the thing. Again, we could do all the constraint adjustment stuff that Harlan said, but right now I'm sort of just letting it go. A cool one is when we open the About dialog, boom, a real dialog. And that was completely opaque to us. You know, it was just built on top of what Harlan showed you earlier. And it's also, if you're aware, again, of the navigator stack, it's built into the navigator stack. So your navigator.pops will not ever be broken. And you could even view your licenses. It's exactly the same. And if I do this, I'm popping off the navigator stack. And if I do this, I'm popping off the navigator stack. And last but not least, if I open it up here, you'll see that that extends beyond. And we're getting some exception, but whatever. Now, the last thing I want to show you all here is we have these mysterious buttons called Open Second Window and Open Toolbar. And I want to at least demonstrate Open Second Window because we have the time here. And I'll show you a little bit of what the API looks like right now. Open Toolbar might get a little more involved. Now, I will say this API is still in flux, and I imagine as things go on, it's going to get a little cleaner to add second windows. But the way it works right now is we have the on pressed on that text button. We can make this a async call, and we can await, create, regular. Again, we pass the build context, we pass the size, which we can make 400, 300. And oh my gosh, where is it? There it is. And we have our builder again that we saw earlier. We'll pass the build context there. And we could return a material app with a, what is it, home that has a container in it. Although that won't be very interesting, it'll be hopefully interesting enough. And we might as well see if our hot reload works. Performing hot reload. All right, let's check if that worked out. Yay, there we go. Obviously, I'm rendering absolutely nothing into that container, and I should have done something. But yes, hot reload mostly works. But as you could see, you could open up another window just like that. There will also be, we're kind of building it out right now, but there will be some helper widgets, especially around things like satellites and stuff, because, you have all the constraint adjustments. You kind of want to keep it in the same type of widget tree ideas, so we're toying with that as well. And that's pretty much it. Cool.
All right. Yeah, so as Matt said, this is all still in flux. This is all still in flux. It is all proposed upstream by now. We are getting feedback from the Flutter community, but yeah, we would love all the feedback that we can get. So this is like there's I think a 12,000 total line of code set of PRs into the engine and into material. A lot of it is still boilerplate. We are going to work with the Flutter team, Flutter developers, Flutter community to make this better, to make this just work for people. Yes, macOS support will come, Linux support will come. The deal is that so for example, the behaviors that you saw here for like satellites, right? This makes sense on a floating window, desktop-like Windows and macOS and generally Linux is, but it's not necessarily the case for whatever comes in the future, right? So that's why those behaviors will actually be platform dependent. But what you can, as an application developer, you can actually rely on this is my toolbox, right? I want this to behave like a toolbox, right? And depending on the platform, the appropriate behavior for that toolbox will be different because it might just, get bumped into your Android navigator again and be like something that you have to choose from and open every time. But if there's space on the screen, then it will open to the side, and all of those things are then possible. So yeah, try it out. Help us out with designing the API, with getting things in, and yeah, thank you. That's that, and we'll take questions. There's many. Great. Come on.
Congratulations, first of all. But how long do you think it's going to take to complete this side quest of making embedders for Mac OS and closing the circle on Linux support as well?
So this work on Windows took us between the primarily Harlan and Matt took us a few months, right? So we do believe we can get to this state, provided that we have any experience with macOS, which we don't, but we didn't have much experience with Windows either. But this isn't, a lot of this code can be shared. So for example, the whole idea of the positioning of all of that, that's shared between all of the floating desktop concepts. It might need to be rewritten in Swift or whatever because macOS. And there's definitely lots to do in kind of making it all tested, integration tests, making sure that it doesn't break on you, and getting people. But I do believe we will get help. Like just looking at the response from the community over the past 3-4 days, and before then we saw that people were aching for it basically. So I do believe that there's if we can rally behind it, then this can really be relatively quick, and it can be great. You saw Cosmic yesterday being shown off, and then the whole tiling story. I'm going to come back to this because that's a great example of, but I can do this on my own in my application, right? But no, you can't, because on the paradigms of your desktop might actually be very different than what you assume, right? So yeah, help.
If I look to the Linux side, so we've multi-view support was already in Windows, which is part of the reason the Windows was done first. The Linux one is about half there. It's upstream. It's being upstreamed sort of halfway, so you can see the commits in Flutter engine right now.
So I will repeat the question for the recording. So do we anticipate that the Linux stuff will come before macOS? Ideally, they will just come both together, right? Because it's parallel work, right? So if we're able to get people to work on it, like we only have so many hours in a day, and yeah, as I said, macOS is probably the most difficult stuff for us to touch, because we would have to get it from the ground up on how to do this. The actual multi-view, because the biggest work that's already happened in Flutter so far was that Flutter could only draw into a single window because it just had a window singleton embedded all through itself, and the Flutter team has done that work on Windows and macOS, but there's more to do, but there will always be more to do, right? So Android and iOS, they today again can only draw into a single window, and this has to yield to that, right? We can't break existing applications, we can't break existing use cases, so this has to yield to that, which means that in whatever we do, whatever behaviors we change, they will have to be backwards compatible so that your app still continues to work in exactly the same way. But if you happen to bring your app to the multi-window world, and the environment you're in is going to yield to that, then let's use that.
Another thing to mention across platforms is that Android devices are now getting more sophisticated and may have desktop type modes, in which case you want the system to kick into behaving like a desktop, not continue to be constrained by the way Android has been in the past. This allows that to come in.
Hi, so I'm an application developer targeting Ubuntu specifically mainly. Can we maybe zoom out a little bit? And over the last 15 years, Ubuntu has had a lot of change in what their recommended way for application developers is. So we started off with Python and GTK, and then switched over to C++ and Qt, then sort of went back to the GTK, and now there's the Flutter. Can you maybe talk about what Ubuntu Desktop is looking to get out of Flutter, and what opportunities it gives you that you might not have had up until now?
So one thing that I can say write your app in whatever you're comfortable with, right? That's really the goal here. And like, I wouldn't say that we're switching over or anything. Like, this is like, part of the reason why we ourselves forced ourselves into Flutter is to see what the developer experience there is. Because we know that the people are out there already. We just want to bring them over. So if you're happy working in whatever framework you're happy working in today, then just continue to do that. If you want to jump on the Flutter bandwagon, yes, please, all of that. But I wouldn't say that we in Ubuntu are, like we would rather you write an app in Flutter at this point, because there's really no reason for you to migrate if you want. Robert?
Yeah, I was just going to talk on Ubuntu Desktop. So one of the reasons that we picked it for the apps that we're developing is simply hiring people. Like, finding a competent GTK developer versus hiring a Flutter developer is very, very different. So that's one of the reasons that we're using it. And yeah, if the community feels the same for their own apps, then we can see them going the same way.
To add on to that, another reason why we're using it is to help test. Is to really kind of double down on testing the framework to make sure it does what we expect it to do. If we can't build our own apps for Ubuntu Desktop, we can't expect app developers to do it. So it's a great testing ground for us. And it's really just about enabling the ecosystem, and there's a ton of Flutter developers out there.
And to say we've been really happy with it. So, it's working really well for us. So I think we can recommend it on that sense.
There you go.
Thank you. Hello. My question is, given that many desktops right now are migrating to Wayland, are you planning to support X11 at all, or is that not the objective here?
Like, as Alan had on his slide, yes, we will support X11 because, on the one hand, because it's easy in the sense that we will already have been built the whole logic of what this has to be on that side. Like, that's our current plan. I'm not sure if, like, we're not sure yet, like, what's going to be the order of things in that sense. Obviously, Wayland we will enable, and we will do as much as we can on Wayland. X11, yes, that's also on our list. X11 is not going away as quickly as we would like it to go away, potentially. So that's we don't want to put that kind of in front of a Flutter developer again, like, okay, so but I do this, and then my app won't work on X11. So again, to kind of make it as broad as possible and support it, yes.
Thank you.
Anyone else? All right, perfect. You get 15 minutes back from us. Thank you so much.